Hello, my dear children. We have started the first chapter of chemistry, that is the chemical reactions and occasions. But we are doing the types of chemical reactions, right? This was the topic going on, and today it is going to complete types of chemical reactions. This is the last topic of the chapter. The first, second, and third, fourth, these sections we have covered already. First was combination. Second was decomposition. I think you know what is a combination. When A plus B equal to AB, it is a combination. Decomposition reactions is a vice versa. When AB is equal to A and B, it's a decomposition reaction. Third is your displacement reactions. Displacement reaction we have covered in the last lecture. Displacement reaction is like AB plus C arrow CB plus A. Displacement reaction, because C is more reactive than A, so it has displaced A from the solution and occupy the position of the A. And the fourth was double displacement or double decomposition reaction. It's a double displacement reactions. Double displacement reaction when AB plus CD arrow AD plus BC. It's a double dissociation or double decomposition, or you may say double displacement reaction. So these four reactions we have covered already. Again listen: combination A plus B AB, decomposition AB arrow A plus B, displacement AB plus C. C is more active than A, displaced A. Double displacement AB plus CD arrow AD plus BC, or you can say it's a double decomposition reaction. On fifth, last reaction I'm taking. The fifth reaction is oxidation reactions. Oxidation and reduction reactions. Write down fifth reaction. So today topic is number 5, redox reactions. Redox reaction. Red means reduction. Ox means oxidation. Redox reaction, oxidation. It's a combination of reduction and oxidation. These two reactions go hand by hand in some of the occasions. But I am taking first what is oxidation, what is reduction. Okay? So redox reaction, or you can say it's oxidation reduction reactions. It's oxidation reduction reactions. Write down oxidation reduction reactions. Right? One by one I am taking. First, oxidation. Oxidation means there are so many definitions of oxidation, but up to your level, oxidation is addition of oxygen. Just addition of oxygen. Like in my first lecture, magnesium ribbon was burning in the presence of air. It is a oxidation reactions. Addition of oxygen. Oxidation reactions. It is your copper plus oxygen. It is oxidation reaction. There is an addition. Carbon plus oxygen. It's an addition of oxygen. It's oxidation reactions. So what is this? Oxidation. It's addition of oxygen. And removal of hydrogen. Removal of hydrogen. Oxidation is the addition of oxygen, removal of hydrogen. I am taking examples of removal of hydrogen. H2S plus bromine arrow 2HBr plus sulfur. Removal of hydrogen. So it's a removal of hydrogen. Hydrogen removed. You can see hydrogen removed from H2S. So it's a removal of hydrogen. It's an oxidation reaction. So oxidation is the addition of oxygen and the removal of hydrogen. Remember this. These are all reactions of oxidation. You can balance it. It's very simple. Today we will balance it again, all the reactions. Again we will do the practice of balancing. First we are going to complete the topic. So you can write here 2 and 2. This, I think it's balanced 2 and this is 2. This is all balanced. So this is oxidation. Right? Now I am taking a reduction reaction. What is a reduction? Right. Reduction is the addition of hydrogen. Addition of hydrogen. It's a reverse It's addition of hydrogen and removal of oxygen. And removal of oxygen. So write down, it's the addition of hydrogen. Hydrogen plus sulfur. Addition of hydrogen. It's H2S. Addition of hydrogen. Copper oxide plus hydrogen. Removal of oxygen. Copper plus water. It's a removal of oxygen. So always remember oxidation and reduction. Oxidation is the addition of oxygen and removal of hydrogen, right? Hydrogen only. And reduction is the addition of hydrogen plus chlorine. Hydrogen plus chlorine, arrow 2HCl. Addition of hydrogen. So these are addition of hydrogen and this is removal of oxygen. Copper oxide plus hydrogen, arrow copper plus water. So I think you know what is oxidation and what is reduction reaction. Now I am writing few reactions. Let us identify which one is oxidation and which one is reduction. I am going to write few reactions on the blackboard. Let us identify which one is oxidation and reduction. So always remember oxidation is the addition of oxygen, removal of hydrogen, and reduction is the addition of hydrogen and removal of oxygen. So I am going to write some of the reaction, right? First reaction is, the first reaction you may write is MnO2 plus HCl or MnCl2 plus water plus chlorine. Write few of the reactions. After that we will identify. Next is zinc oxide plus carbon, arrow zinc plus carbon monoxide. Next is Fe, it is your H2S. It is your potassium iodide plus, it's of the another way. I am not taking this reaction because in this reaction the concept is different. The third you can take H2 plus bromine, arrow 2HBr. 2HBr. So let us identify all these reactions first. In the first reaction, what is going on? MnO2 plus HCl. MnO2, you can see it is MnO2. But in this side it is MnCl2. This means it has removed oxygen. So what is, you can write reduction. It's a reduction. MnO2 is reduced. You may write it, it is reduced. MnO2 is getting reduced because it is removing oxygen. And in HCl, in H there is an addition of oxygen. It becomes water. You may write addition of oxygen. So it's oxidation. HCl is oxidized. So reduction, one is going reduced, other is going oxidized. In this reaction, zinc oxide plus carbon, oxygen is removed. Simple zinc it becomes. ZnO to zinc, removal of oxygen. So this is one of the reduction reactions. Reduction reaction. It's H2 plus bromine. It's 2HBr. Again, it's addition of hydrogen. It's a removal of oxygen. It's addition of hydrogen. It's a reduction reactions. So this means both are the reduction reactions. Because in both reactions, there is addition of hydrogen and removal of oxygen. So what is this? This is a redox reaction. Redox. What is a redox reaction? Where reduction and oxidation go hand by hand, simultaneously. One is reduced, other is oxidized. MnO2 plus HCl, manganese dioxide getting reduced and HCl getting oxidized. One is reduced, other is oxidized. So it's one of the redox reaction. If in a compound, one reactant is oxidizing and other reactant is reducing simultaneously, such type of reactions are called redox reaction. What is a redox? Write down. Redox, where reduction and oxidation go parallelly. One oxidized, other reduced. So this is all about your oxidation and reduction reactions. There are so many other methods to identify. In higher class it will come. So this is a very simple definition. Oxidation and reduction. Now you can write, the topic is corrosion. After that topic is corrosion. It's called, you know, when iron comes in the presence of air, iron article, any iron article, when come in contact with air, it get rusted. It get a coating of reddish brown color. Corrosion is the, I will tell you the definition sooner. First write down reddish coating. It's a reddish coating, a reddish brown coating. When iron is exposed to air for a long time, it oxidized. It oxidized in the presence of air and a reddish brown coating formed around the iron article. Now copper. If the copper article comes in contact with air, then a green coating. Green. The coating is of the green color. Green colored coating. If the silver article comes in contact with air, the silver article acquire black coating around it. Get grey or blackened color, black coating. So what is this going on? This is a corrosion going on. What is corrosion? Right on, it is a eating away. It is eating away of metal, reactive metals. Right on, reactive metals. It's a eating away of reacting metal in the presence of atmospheric gases. In the presence of air, you may write simple. In the presence of air, you may write when exposed to atmosphere. Anything you may write when exposed to atmosphere. So in all these reactions, they are oxidizing. Addition of oxygen, oxidizing they are. So this is corrosion. Rusting of iron. Rusting of iron is the best example of corrosion. Rusting of iron. In detail, how the iron get rusted will come in higher classes. So what is a corrosion and what are the examples I have shared with you? Corrosion is just eating away. What is eating away? Eating away means these iron article loses the weight after some time. Why? Because they get rusted. It get broken. It get broken when when it get oxidized in the presence of air. When you expose these articles to the atmosphere for a long time, they get oxidized. Reddish brown coating, green coating and black coating. These are all rusting. These are all corrosion examples. So during corrosion, the articles loses the weight. They get broken up. This is corrosion. So this is all about in this chapter, but I will tell you what I'm going to do the practice for some writing. My next topic is how to write the formulas, writing the chemical formulas. Next topic. Now, right, I will send you the link. This is my request to you. Download that link. In my next lecture, I will send you one link. Download the link. And in that link, I have given some anions and cations with their charge. From that, it becomes very easy for you to make the formula and to balance. Now, my topic is how to write the chemical formula. Now, I am giving you some examples. For example, I want to write the formula of, I'm taking typicals, ferric phosphate. Ferric phosphate. If I want to write the formula of ferric phosphate, how will you write? I know ferric is iron 3 plus and phosphate is 3 minus. So it's become very simple. The formula become FePO4. So once you know the metal name with the charge, the formula is very easy to calculate. That's as I said, I will send you the link in my next lecture. You download that link, and in that link there I made a file where there's a cations, anions, names are given with their charge. This become very simple for you to making formula. I'm taking 4 or 5 examples for this. Now write down second. Second is, it is your cobalt nitrate. Cobalt nitrate. Cobalt 2 plus, nitrate NO3 minus. The formula become crisscross. The formula become cobalt nitrate. Very simple. Cobalt 2 plus, nitrate NO3 minus, crisscross. The formula become cobalt nitrate. Next is third. Now I'm taking cupric chloride. Cupric chloride. Cupric is 2 plus, chloride is minus. Cupric is 2 plus. So it crisscross, the formula becomes CuCl2. If I write cuprous chloride, cuprous, it is ic, it is us. Cuprous chloride. Cuprous is plus, chloride is -1. Formula becomes CuCl. So it's a cupric chloride, CuCl2. It's a cuprous chloride, CuCl. In the similar way, I'm taking ferrous sulfate, ferric sulfate. ferrous sulfate. Ferrous is 2 plus, sulfate is 2 minus. Cancels. Formula become FeSO4. Ferric sulfate. It is Fe 3 plus, sulfate is 2 minus. Crisscross. Formula become Fe2SO4 thrice. This is the formula. Very simple. Crisscross. Ferric and ferrous. Ferrous is 2 plus, ferric is 3 plus. So this is the formula. So it's become very much easy for you to make the formula. It become very easy to become the formula, make the formula only then if you know the cation and anion names with their charge. Now one more example I am taking. Now you can say ammonium dichromate. I am taking peritypical now. Ammonium dichromate. Ammonium is NH4 plus, dichromate is Cl2O7 2 minus. It's a typical formula, not in your syllabus. Even then I am taking ammonium dichromate. Crisscross, it become NH4 twice, dichromate, Cl2O7 2 minus. No need to write. Crisscross. So this is a very simple way to find the formula, right? Now after that, this is the practice to make the formula. So I will give you some of the formulas. You can make yourself by taking the help of that file. Now write down how to balance the equation again. Again I am taking balancing equation. Now hope this is my last lecture to balance the equation. I am taking 2 equations to balance it. After that you become the master of to balance the equation. Write down the equations are. Now I am taking your equations. First equation I am taking KMnO4 plus HCl, KCl plus MnCl2 plus water plus Cl. So let us balance Cl2. It's a very lengthy equation. Let us balance it within seconds. How? I have told you in my last lecture, whenever you want to balance the equation, this is my last lecture to balance the equation, right? Now listen to me carefully. Whenever you want to balance any equation, first of all you find out which one is a simple molecule. This is a complex molecule because it has a different atoms, different atom. But chlorine is a simple because Cl2, same atom. May underline, it is a simple molecule. First step, KMnO4, write down along with me, plus HCl, KCl, plus MnCl2, plus water, make it in this form. Molecule to atom. It is Cl2. This is called molecule to atom. Now the species to whom you have converted molecule to atom, balance it at the end. You will not balance it. Balance it at the end. Listen, the species to you have converted the form, that is molecular form to atomic form, balance it at the end. Rest you can balance now. Now it is your KMnO4. Potassium is 1, manganese is 1, oxygen is 4. Write it 4. Make the boxes if you want to make the boxes. This is your wish. Let me write the boxes again, but in exams no need. When you become perfect, no need to make the boxes. This is my boxes. Let us balance it. It's K1, manganese 1, oxygen is 4. Write oxygen is 4 out the box. Oxygen is 4. I told you, whenever you put any number, immediately see the number of other atom get changed. It is hydrogen 8. This side hydrogen is 8. This side hydrogen is just 1. Outside the box write 8. Right? So now 8. This is, I think it is all balanced. Potassium balanced. K1, manganese 1, oxygen 4, hydrogen 8. What left? Chlorine left. This is a turn of the chlorine now. Now it is 8 chlorine this side. This side 1, 2 and 1, 2, 3. 1 plus 2, 3. Left 5. Right 5. Now it is 5. 1, 2, 5, 8. 8 chlorine this side, 8 chlorine this side. No, after that what you will do? Now this equation is balanced now. But my last step is, if the number is odd, multiply the whole equation by 2. If the number is odd, multiply the whole equation by 2, reaction is balanced. Now this is the final answer. 2 KMnO4 plus 16 HCl arrow 2 KCl plus 2 MnCl2 plus 2 into 4 8 plus 8 water plus 10 chlorine. Now you will write 10 Cl or you write 5 Cl2. So this is better to write 5 Cl2. Your reaction is balanced within seconds. So this is the best way. Now I'm taking one more. After that I will give you the occasions to balance. You balance the occasions, do the practice. How will you do the practice? First you will make the formulas. After making formulas, then you balance. Today I have given you very important lectures how to make the typical formulas and to balance it. Now I'm taking one more occasion. Write down K2Cr27. It's a potassium dichromate plus H2SO4 plus H2SO4 arrow K2SO4. It's a chromium sulfate Cr2SO4 thrice plus water. So it's a potassium sulfate, chromium sulfate, water, and it is also given oxygen. Write down plus oxygen. This is all. Okay, let us start. It seems it's very difficult, but it's very easy if you follow the same path. It's a different atoms. It's a complex. Different atom, complex. Different atom, complex. Only this oxygen is simple because it is made up of same atom. Let us do the first step. K2Cr27 plus H2SO4 arrow K2SO4 plus Cr2SO4 thrice plus water plus write down single oxygen. You will balance this at the end. Rest you balance please. Potassium 2, chromium 2. Now how much sulfur? Now you can count. Your sulfur is 1 here. This is 1 sulfur. And here sulfur is 3. You can check sulfur is 3. This means 3 sulfur and 1 sulfur. So how much? 4 sulfur. Right here 4. Now let us see hydrogen. Hydrogen is where you write any number. At once see the other atom's number get changed. Okay. Now hydrogen is 8. This side is no hydrogen except this 8. This is your, make it 8. Right here 8, 4. Now I think potassium balanced K2. It's K2, Cr2, and it is sulfur. How much sulfur? Sulfur is 3. Sulfur is 4. I balance sulfur 4. Okay, hydrogen is 8. Everything balanced, left with only oxygen. How much oxygen this side? 7. It is 7 and it is 4, 16. 4 into 4, 16. 16 plus 7. So it's 23 oxygen. Let us see here. It's 4 oxygen plus how much oxygen? It is 4 into 3. 4 into 3, 12. 12 plus 4, 16. 16 it is. Now you want 7 because 16 plus 7 become 23. You write here 7. Write here 7. Number is odd. So same, the number is odd. Multiply the whole equation by 2. Now once again check. Potassium is 2, Cr2, sulfur is 4, 1 sulfur here, 3 sulfur 4, 8 is hydrogen, and oxygen is 4 into 4, 16, 16 plus 7, 23. Now after that, this you can see 4, it is 4 into 3, 12, 12 plus 4, 16, and multiply this whole equation by 2. Now answer is, it's 2 K2Cr27 plus 8 H2SO4 arrow 2 K2SO4 plus 2 Cr2SO4 thrice plus 8 water plus 14 oxygen. You may write 7O2. So this completed my today's lecture. Now what you have done today, you have done one reaction, oxidation and reduction, how to write chemical formula and how to balance it. In my next lecture is very important for you, because in the next lecture I will make the story of the full chapter and I will take the questions. Thank you.